Hi, folks. We're going to take a look at page 345, number 12. So in part A, they ask us whether these 3 points form a right triangle. Okay, so if I take the points, draw them out, if I wanted to show that they create a right triangle or not, so say this is A, B, C. Okay, well, one thing we could do is we could find these vectors from, say, B to A and B to C, and then from C to A, and take their magnitudes. And once we have their magnitudes, we can start finding the angles inside the triangle, okay, using the cosine law. All right, but when you think about that, that's a fairly long process because say you found this angle first, that wouldn't be 90 degrees, and then you found that angle second, that wouldn't be 90 degrees. Then you could just subtract and see if the third vector, subtract from 180, see if the third vector is 90, but that means doing the cosine law possibly 2 times. And because they're specifically asking us if it's a right triangle, I think there's an easier solution because right triangles satisfy Pythagoras. All right. So I think the easier way, the quicker way of solving this is to just define the 3 magnitudes and then see if the squares of 2 add up to the square of the third. Okay, and that'll be much faster than having to do the cosine law 3 times and finding magnitudes first. All right, so let's start by finding the magnitude of AB. All right, so that's the square root of, so AB, remember, second minus first, so 2 minus 1 is 1, so 1 squared, plus 2 minus negative 1, so 3 squared, so plus 3 squared, and then 2 minus 1 is 1, so 1 squared. So here it's going to give us 9, 10, 11, so square root of 11. Okay, and let's take a look at BC. All right, so square root of, so 4 minus 2, that's 2 squared. So I'll just write it out, 4. Negative 2 minus 2 is negative 4, so negative 4 squared is 16. And then here, 1 minus 2 is negative 1. Negative 1 squared is 1. So here we've got 16 plus 1, okay, square root of 21. And now let's look at AC and its magnitude. All right, so what do we have? We have 4 minus 1 is 3, so 3 squared is 9. Negative 2, negative 2 plus 1 is going to be just 1, so 1 squared. All right, and plus 1 minus 1 is 0, 0 squared. So in the end, we have 9 plus 1 equals 10, so square root of 10. All right, and it looks like we do have something that's going to work out, because if I take the magnitude of AB squared plus the magnitude of AC squared, what do we have? We have 11 plus 10, which is 21, and then if I take the magnitude of BC squared, we have square of root 21 is just 21. And so what we found was that yes, it is, okay, since Pythagoras has been established. Since Pythagoras, I'll say since Pythagoras holds. All right, so keep that in mind, that while we'll normally use trigonometry to find an angle, in this case here, because we were specifically looking for a right angle in a triangle, we could just see if Pythagoras works. All right, so that was A. Let's look at B. So it asks us if these points are collinear. All right, so we might even get inspiration from what we would have done back in grade 9. How would we have shown that 3 points lie on the same line? Well, what you might have done in grade 9 is you would have found the slope between 2 pairs of lines, and you would realize that the only way for them to be collinear is if the slope were the same. Okay, we're going to do something a little similar. Because if I were to join, so say this is P, Q, and R, okay, and they're collinear. If I were to join P and Q, and then I were to join P and R, well, what would be the relationship between these 2 vectors? They would have to be parallel. In other words, they'd have to be scalar multiples of each other. That if they were not collinear, and I joined P to Q and then Q to R, we would see that if they weren't collinear, I would not be getting vectors that are parallel to each other. So essentially, that's all we have to do is show whether the vectors are parallel. So if I take the vector PQ, okay, let's see what we get. We get, so PQ, so 2 minus 1 is 1, 4 minus 2 is 2, 6 minus 3 is 3. And then let's take the vector PR. Okay, and what do we get? We get negative 1 minus 1 is negative 2. And then here we get negative 2 minus 2 is negative 4. And here negative 3 minus 3 is negative 6. And I see that PR is just negative 2 times the vector PQ. Okay, and so we've shown that they're scalar multiples of each other, hence they are. Okay, yes, they are collinear since vectors are parallel. All right, there you have it. So in this case here, we actually didn't have to do a lot of calculations. So in part A, we were able to find the side lengths of the three sides of the triangle and show that they satisfy Pythagoras. So that showed that it had to be a right angle triangle. And then in part B, we just created two vectors with the 3 points and showed that they were parallel. Hence, the 3 points had to be collinear. Okay, that's it for this one.